Yo, yo. What is up, fellas? We're here, we're here, and we're here, and we're here. That's as big as it goes. Get comfy with the AOC. Oh, that's why I got big last time. Comfy with the AOC project description. With the AOC. With the AOC. With the AOC. Get a little gold in the background here. Just to get all comfy. Day 17. Still on this problem. With the AOP and the AOC and the AOP. So at a minimum in this stream, what I wanted to do was, so last time at the end of the video, we had written some bounds for so that we would print out 2 on the first run of this program. So we wrote these bounds here. And so the minimum thing that I want to do is actually just like test, is just to test those bounds and see if they actually print out a 2 or not. Just to make a little bit of progress. So it seems like the bounds that we wrote down were 8. Why does this keep going away? Okay, that's good. Okay, it looks like the bounds were basically B1 has to be greater than or equal to this number in binary -6 minus C minus 5 bit shifted by 3. And if it's less than or equal to this value, 10111 plus 6 plus C plus 5 bit shifted by 3. Then by the math that we did in the last video, then it should be that the thing that gets like, then it should be the case that basically B4 is going to be like this number here. It's going to be of this form. It's basically going to be like between these 2 numbers here. And then when we bit shift it by 3 and do it out to the screen, it'll print out a 2. So yeah, so that's it. So the interesting thing I'm kind of noticing is that C just appears kind of like in both of these terms. And so this range is dependent on C basically. Like if C is 0, then B just basically has to be greater than or equal to like this number minus 11 or like this number plus 11. But if C is like a million, then we just like shift it over. Then we just like shift it over a million. It's kind of like, all right, let's see what this number is. This is 2 to the 1. 2 to the 1, 2, 3, 4. So this is 2 to the 4. And this thing here is 2 to the 4 plus, let's see, 1 plus 2 plus 4, 7. So this is 2 to the 4 plus 7. So basically this is 16. And this is 23. So basically, if B1 is greater than or equal to 16 minus 6, which is 10, minus 5, which is 5. So it's 5 minus C. It's this whole thing. And then over here, if we do 23 plus 6 is 29. And then plus 5 is 34. Hold on. So this is 5 minus C, bit shifted over by 3. So yeah, so this is 29 and then 34 plus C, bit shifted over by 3. Okay. Okay. So let's just let's just do this. Let's just fix C at 0. Sure. Well, I wonder if we can choose a value for C so that these are going to be powers of 2. Like, could we pick C as 3? No, that's not going to work. All right, let's just pick C is, I don't know. Okay, fine. Let's just do C equals 0. It doesn't seem like there's a nice value to choose. So basically then the left side here is 5 bit shifted over by 3. I think that's just going to be 0. Like 5. So we have 4, no 2s in this. So this is bit shifted over by 3. So you basically chop off this, chop off this, chop off this. So yeah, this is going to be 0. So B is greater. So as long as B1 is greater than or equal to 0, and it's less than or equal to, all right, 34 plus 0, bit shifted over 3. So 34, bit shifted over by 3. All right, so 34 is going to be a 32. It's basically 32 plus 2. So 32 plus 2 is like, so there's no 1, there's 1, 2, 4, 8, 16, 32. This is 32. We're going to bit shift this over by 3. So we'll chop off these 3 zeros and we just get a 100. So by the math, if B1 is greater than or equal to 0 or less than or equal to 100 and C is equal to 0, then we will print out a 2. And I notice that A doesn't appear anywhere in here. So I guess it doesn't matter what A is. Let's just verify that. So oh yeah, let's I don't need this anymore. So basically feel like we've made a grave error here because B gets set from A shifted over by 3. Um, hmm. What did I do in this? Let's do this. Yeah, I think that was wrong to say that. I think I kind of thought that this A was like B2, some something like that. But no, that's not the case. So so what was the logic we went through? We were like, all right, B4 has to be B4 has to be in this range for it to get printed out. And then what do we kind of say? Like B4 has to be in that range, and we're kind of working up. So if B4 has to be in that range, like B3 has to be something so that B4 is in that range. And so like it's kind of like the like range that B3 has to be in is like this, and then it's kind of like the range it's so like kind of so like B4 has to be in this range, but so B4 has to be in this range. Okay. So in order for B4 to be in this range, B3 has to be kind of like in this range thing here. Uh, and then in order for B3 to be in that range, B3 is equal to B2. So like B2 has to be in like this range, and then B1 has to be in this range. So I think that's kind of where we uh, kind of leave off a little bit, where we're like, all right, so B1 has to be in this range right here, which is it's this thing minus 6 minus C minus 5. And B1 has to be 1, 1, 1 plus 6 plus C plus 5. So B1 has to be here. But so we have to go up one more step in order for B1 is equal to a bit shifted by 3. So it's almost like if we just like substitute out, I feel like this isn't what I did up to this point, but maybe I did it by accident. But we know B1 is equal to a bit shifted over by 3. So if we know a bit shifted over by 3, like if B1 is less than or equal to this, then a bit shifted over by 3 is equal to this. And now we need to do the inverse of A being bit shifted over by 3. Okay, let's not worry about what like this a kind of because this is like a destructive operation where like we actually can't compute the inverse if A is like less than 3 bits long, basically, because it's just going to zero out. So, but kind of the intuitive inverse would be like to take this number and then just like shift it back this way over by 3. And so if we kind of like take A and shift it over by 3, dang, we are losing like okay, even if A is a big number, if we like bit shift it over by 3, um, we're gonna like chop these off. So we can't just bit shift it over and then bit shift it back and like get our number back. But if we do, that would introduce a bound. Like if we take A and we bit shift it over by 3, and like this gives us a number like A1, and then we took like A1 and then we like did it back by 3. It's like, what number would we get? We can kind of like think about, yeah, this in terms of ranges now. It's like if A was equal to 110, then A bit shifted by 3 is going to be equal to 0. And then A1 back over here is still going to be 0. But if A, so kind of, I don't know, like 3 basically went to 0. This isn't 3. This is 1 plus 2 plus 4. So this is 7. But okay, and then we do like, what if A was like 1000 and we did A bit shifted over by 3, that would give us a 1. And then if we did A1 bit shifted back over by 3, we would get this back. So basically it depends on what the last 3 digits are. If they're all 1, that means that A1 is going to be A minus 7. Well, I mean, A1 bit shifted over by 3 is going to be A minus 7. So basically it's going to be, yeah, it's going to be between A. So if we call like the number that we get back A2 is like you take A, you get A1, and then you shift it back. It's going to be at most A, and it's going to be at least A minus 7. So this number like becomes an A1. And then when you get this back here, this is A2. So this number may go down by 7. It may go down by 7 when you do this. So like if this number was unchanged, then you could just do this like bit shift down by 3 and well, this is kind of weird actually, because well, yeah, okay. I was gonna say like whatever happens to this number is gonna happen to this number as well. So like if this thing like loses 7 and then goes back, like it's gonna lose 7. But this number is gonna be uh is like this is just a variable. So I'm a little confused, like what we're doing here with like variables and stuff. Like, I almost want to say like, all right, this number is going to be, this might lose its value by 7. So in order to kind of do this, you would shift this over. You'd shift this over by 3, and like the resulting number. Okay, so here's where I don't know. It's like confusion after confusion because we didn't actually. Yeah, I guess we do want to recover A. So we're basically not sure if we can recover A. We're going to recover a number. We're going to recover something close to A. We're going to get the number A. And then minus 7. We're going to recover a number that is somewhere in this range, like A, from like A minus 7 to A. So yeah, okay. So like this inequality has to reflect like we can't we're gonna get a number that yeah is maybe 7 less than A. So we could just, but we don't know what that number is. So we can't even call this A. Like we call this like A hat, I guess. This is kind of like an approximation of A. And what are we saying? That A hat, if A hat is, I guess where I'm getting really confused is it's almost like we're like trying to recover A, and if we could, then we could say that A is in this range, but well, here's um I what is this even? Can we do something like this? Like where we like get a number where it's like, I mean, we're gonna get this number, which is basically like it's number X. It's like nested inequalities. It's like X is greater than or equal to A minus 7, and it's less than or equal to A, which is less than or equal to like this thing here, shifted to the left by 3, and this thing shifted to the left by 3. Yeah, I think this is right so far. I guess where I'm getting hung up now is where we kind of get this inequality now, and we're kind of like doing the same thing here. And like, do we also have to kind of bound this within like this range of 7 kind of thing, where we have to worry about its bits coming back? I guess this really requires us to go back to, it's almost like, to borrow a term from probability theory, it's like, what is the generative story of like this number here, of like this number b1? Like this number b1, it came into existence. We basically like started with a value a, which has like I don't know, which has some bounds, I guess. I don't know if this is going to be useful, but I don't know. A is like, and we do know that there is a bound. I don't even know if we know there's a bound right now. Okay, fine. I mean, A could just be like a single number. It doesn't even have to be a range. But the generative story is that like A came into, like A is set, and then we bit shifted A over by 3, and that gave us the value of B1. And we know that B1 is in like this range here. Hmm. Okay. I feel like we're getting somewhere with that. But it's lunchtime. I'm gonna go like eat some lunch. Um, we will figure this out next time. See you guys. Peace.